Market basket analysis is a wildly useful skill for any professional. It's not just for folks that work in the grocery store industry. Whether you work in HR, finance, marketing, supply chain, IT, you name it, market basket analysis or association rule mining is a powerful way to discover new and interesting insights from your business data. In this video, I'm going to show you how you can conduct market basket analyses using Excel. And to prove to you that it is wildly useful for any professional, I'm not going to use grocery store data. I'm actually going to use a famous data set from the field of machine learning and show you how you can use market basket analysis in Excel to mine association rules from the famous Titanic data set. So here I am in an Excel workbook. And by the way, you can download this Excel workbook. There'll be a link in the description below to a GitHub, and you can grab the file that you see in this video. So I'm in Excel, and I've got a data set here. And this is a representation of the famous Titanic machine learning data set. But before we get into that, let's talk a little bit about what market basket analysis is. Market basket analysis is a technique where you take a data set and you mine from it interesting associations. So for example, in the classic grocery store industry example, you might have an Excel table where all of the columns of the table are products in a grocery store, meats and cheeses and milk and cereal and who knows what. And then each row in that table in Excel is an individual customer who bought a bunch of items at the grocery store and checked out. And those are known as market baskets. So each row is a market basket, and each column is a potential product. And how this is represented in Excel is each individual cell in the table is either a 1 or a 0, which essentially just says, did a person buy this particular product in their market basket? And what can happen then is you mine that data, you mine these association rules from the data, and you find very interesting patterns. So for example, in the grocery store industry example, to continue on, you might find that people who buy bread also buy mayonnaise at an extremely highly rate. Those things are highly associated because in the United States anyway, bread is often bought to make sandwiches, and mayonnaise is a common condiment that Americans put on their sandwiches. So that's an association rule. Two products that are bought together more often than you would expect. And then you do things like, well, maybe I'll create a coupon special where you buy a loaf of bread and you get a discount on mayonnaise, and the idea being that you would sell more of both products. Now, this idea of mining out association rules is so powerful that market basket analysis can be used for basically any type of problem. And that's why I'm using the Titanic data set in this video, is to prove that to you. So what we have here is a table of data. And what I've done is I've engineered some columns here so they can just have 1s and 0s in them to tell you whether or not any individual market basket had this particular characteristic. So let's talk about what this means in practice. So let's take a look at this row right here, row number 2. So each row isn't actually a market basket in this analysis. It's actually a passenger in the Titanic data set. So this passenger was not in first class, was not in second class, they were in third class. They were not female, they were not a child, they were an adult, and they were traveling solo, so on and so forth. You can see here what I've done is I've taken characteristics of a Titanic passenger and turned them into product columns in this market basket analysis. Now, what's really, really super powerful with market basket analysis is that you can actually guide the association rules. So typically in a market basket analysis, you just throw a bunch of data into the analysis and it just shows you interesting things that are associated together. So for example, bread, mayonnaise, or maybe meat and cheese, things like that. Things that you didn't necessarily know. Now, there's a legend that goes something around the idea that a grocery store found that beer and diapers were highly associated, and then they were able to capitalize on that by making a special where they would have, you buy some diapers and you get a discount on beer. That's legend, but you get the idea. But you don't have to do that. You can actually guide the market basket analysis. You can say, hey, look, I'm interested in this thing right here, and then go mine all the association rules that are highly associated with that. And it's a little bit abstract, so let's cement it for this particular example. In the Titanic dataset, what we're highly interested in is knowing what patterns in the data are associated with survival. Not surprisingly, right? I mean, the Titanic was a disaster. So the data set is designed from a machine learning perspective to train predictive models that says, look, based on these characteristics of the passengers, how likely are they to survive based on that? And you can use association rules to actually do this. So what we're going to do in this particular video is show how you can peg or fix survived and then ask the algorithm, ask the market basket analysis to find all of the other things that are highly associated with survival. Pretty cool, right? What this shows you is that anything that you can think of, any sort of characteristic, any sort of behavior in your business data that can be modeled as a column and then have a 1 or a 0 in it to denote presence can be analyzed using market basket analysis. And these association rules are wildly useful. I've personally used them to support marketing, to support product management, to support finance. You can use this all over the place. But enough of that. Let's go ahead and dive into actually doing a market basket analysis in Excel. So first up, we're going to go over here and do a very simple case, which is two-way lift. So essentially, we're just going to say, we've got survived on one side, and we're going to say, hey, market basket analysis, go find out of all the remaining columns of data in that table that I just showed you, which one is most highly associated with survival. So just one column of data or one feature or one product, depending on how you look at it, which one of those is most highly associated with survival. To make this a little bit easier in Excel, what we're going to do is create a few pieces of data here. First up, we're going to have a cell that just has the total number of transactions. So there are 891 rows of data or 891 transactions. So we just got that here. And then we're going to create a lookup table because I'm going to be using VLOOKUPs in this spreadsheet to help us do market basket analysis. And what you can see here is I've got all the individual features, all the individual columns. There are 16 of them total. And you can see them all listed here. And then I've provided an index for each one of them, which we'll see later on. I'm using that with the solver. We'll talk about that in a bit. And then the frequency. So how many folks in that 891 rows of data, how many individual passengers were in first class? About 24.2%. How many were in second class? 20.7%. How many were female? About 35%, so on and so forth. So this lookup table right here is going to be very, very useful for us to actually do our market basket analysis. First up, we can see here that I'm going to ask the market basket analysis on the right-hand side. I'm going to say, look, I'm interested in survival. I'm interested who survived in the data. And then I'm going to go look at each of the individual other columns, and there are 15 of them total, and then say which one of these is most highly associated with survival. So you can see here I've got the remaining 15 features right here on the left-hand side, and I'm just using survived over and over again. And then next up, what I do is I calculate the combinations thereof. So for example, how many folks in the data were both in first class and survived? And there were 136 of them. How many folks were in second class and survived? There were 87 of them, so on and so forth. And you can see all of the calculations in here, the formulas that I'm using. And once again, you can download this spreadsheet from my GitHub, and then you'll have it at your disposal. This is the base data that we need. And then after that, what we do is we calculate lift. And what lift is a very powerful metric for market basket analysis. In a nutshell, what it tells you is, based on the data that you have, how many times more likely is this particular happenstance, this particular association rule, more likely than chance? And let me just cement that with an example directly here. So what we can see here is first class survival, right? So every member of the first class portion of the Titanic data that also survived, there was 136 of them. And what we can see over here is a lift value of 1.64. And what that tells us is that folks that were in first class were 1.64 times more likely to survive than what we would expect by random chance, which is good. So basically what you're looking for is a lift greater than 1. Anytime you have a lift calculation in market basket analysis that's greater than 1, you have a happenstance, you have an association rule that is happening more often than you would expect. And those are the kinds of things that you want to drill in on. So for example, the best right here, as you can see here in the color coding and the heat map, is this particular situation right here, where people that fit this association rule are 1.93 times more likely to survive. So they're almost twice as likely to survive than everybody else. And if we just roll over here, scroll over, females. So if you're a female in this data set, you're almost twice as likely to survive than males. But we can get more complicated than this. Notice that we're only using a very simple association rule here. We're just saying, look, something on the left-hand side, how much is it associated to something on the right-hand side? But we can increase the number of items. We can make the association rule more complicated by allowing more columns of data on the left-hand side. So what I'm going to do now is show you how you can do that with a three-way lift. And this is where the solver comes in. So I'm just going to go ahead and scroll down here so you can see this a little bit more. So here's the problem. Actually, no, I'm going to scroll back up real quick. Sorry about that. So when we're doing a two-way lift, right, we're only looking at two things simultaneously, and especially if we're pegging the right-hand side, which is, quite frankly, the most interesting way to use market basket analysis in my experience. When we peg the right-hand side, going through all the various permutations on the left-hand side is actually kind of easy, right? Because you can see here, I have 16 total columns of data, 16 features. If I peg one as survived on the right-hand side, then I just have 15 rows because I just have one association rule for each one of the remaining 15 columns of data. And that's pretty tractable. So you can just create a table like this. It's not very difficult and just figure it out. However, the real power of market basket analysis is when your association rules get more complicated. When you peg the right-hand side, let's say, and then you have 2 columns or 3 columns or 4 columns on the left-hand side, the number of combinations in that particular scenario grows exponentially. So it becomes really, really difficult to do this in a manual way using just a simple table like you see here. And this is where the solver comes in. The Excel solver will then, you'll set it up to actually iterate through all the different combinations and it will find you the best one. And let me show you what I mean by that. So I'm going to go do a three-way lift here, which means I'm going to peg survived on the right-hand side. And then because I'm doing a three-way, that leaves me 2 columns on the left-hand side. And what you can see here is I've set up these 2 particular cells to allow the solver to iterate through all of the different possible combinations. Let me show you what I mean by that. So right now we have 1 and 4, but let me change this. I'm going to change it to 3 and 9. And you can see here that things dynamically changed because I've got a bunch of VLOOKUPs in place. Like for example, I've got a VLOOKUP here. So the name of the feature is based on the index. Not surprisingly, I go do the lookup in the lookup table. Same over here. And I'm keeping survived pegged, right? It doesn't change. I'm keeping that as my right-hand side because I'm interested in finding out what are the other features that are most highly associated with survival. And you can see here that the lift isn't so great. So if you're a third-class passenger traveling by yourself, you are way below 1. You're at 0.52. That's not good. Now, what we can do is we can use the solver to essentially iterate through all of these, like try out 3 and 12 and see what it is, and then 7 and 11 and see what it is. And what it'll do is it'll iterate through all these different combinations for you and find the one with the best lift. And I'm going to go ahead and show you how the solver is set up in this particular scenario. So I go to the data ribbon up here and I click on solver. And you've got the solver configuration right here. Now, first up, you can see here that what we're optimizing for right here is the lift. We're telling the solver, hey, we want you to maximize the value in this cell. Maximize the value of the cell AC31 right here, right? We want you to find the biggest value you can. And the solver says, okay, cool, I'll do that. How do you want me to achieve that goal? How do you want me to do that by changing some values? And what we say is, okay, these 2 particular cells right here, W28 through X28, these 2 cells right here, go ahead and manipulate these. Change the values over and over and over again until you find whatever value is the biggest for the lift. And the solver says, cool, I can totally do that for you. And then we say, okay, but we need to give you some constraints here, right? Because the values in these 2 cells, I'm going to move that again, sorry about that. The value in these 2 cells right here need to be constrained because they can't be 1,000 or 22,000 or whatever. They need to be constrained to the values in that lookup table. So we're going to constrain those values like so. We're going to say, look, W28 and X28 have to be less than or equal to 15 because remember, we have 16 total features. The last one is the survived column. So we can only play around with columns 1 through 15, features 1 through 15. We're only using integer values because we need to make sure that the solver doesn't try to do a VLOOKUP into that table with 1.234 because that doesn't exist. So only integers, 1, 2, 3, 4, all the way up to 15. Also, the values have to be greater than or equal to 1. So basically we're saying, look, solver, you can play around with W28 and X28, change the values, but they are constrained between 1 and 15, and they're integers only whole numbers, nothing with a decimal point in it. And then lastly, we're going to say, look, you can find very infrequent combinations of features that are highly predictive, are highly associated with a large lift. So for example, maybe in the grocery store industry, for example, if somebody buys a bottle of Dom Perignon, which is a very expensive champagne, they are extremely likely to buy caviar, right? And if you're a grocery store, you're like, look, those are two very profitable items. Awesome. But how many people actually buy a bottle of Dom Perignon and caviar simultaneously in your grocery store? It's probably an extremely small number of people. So that rule might be very, very good in terms of a very high lift score, but in practice, it's not very useful because you're not going to run a special of like Dom Perignon and caviar because you're not going to sell very many. So this last constraint here says, look, you need to have at least 5% of the rows of data in the data set exhibiting this rule. There we go. These are our constraints. Next up, we use the evolutionary solver algorithm. This is the one you want to pick, evolutionary. And then lastly, we're going to click options here. And what we want to do is we want to set the mutation rate to 0.5. All this is the technical way of setting up the solver for it to iterate over and over and over again on all those different combinations of features to see which one has the biggest lift in terms of survival. So if I click OK here, I can ask the solver to find the best combination of features. And notice right now I'm currently at a lift of 1.495. And I'm using the adult feature with the is triplet feature. And by the way, this means, are there 3 people traveling together? That's what this feature means. So an adult traveling with at least 2 other people, and that lift is 1.495. So I'm going to ask the solver to actually find which one is the best. So now that I've got it all configured, I just click solve, and this will take a couple minutes to run. So what I'll do is I'll just cut over to the final result. I'm going to go ahead and click solve, and let's see what happens. All right, the solver's come back with a solution. It's found through all these different combinations and through all the constraints that we specified, the best 2 features that are highly associated with survival in terms of the lift score. So if I click OK, you can see here that the best combination of 2 features are females in first class, and you can see here that they are 2.5 times more likely to survive than you would expect by pure random chance. And this is awesome. And you also notice too that this also accounts for about 10% of the data. So this is good. This is a good rule. This is a powerful insight. So this is awesome stuff to do. And notice that you can scale this out. I've only done this with 3 columns, right? I've pegged the right-hand side for survived, and I've got 2 predictive features, 2 features to use for the association rules. You could expand this out. You could use 4 or 5 or 6, and all you would do is you would just expand this all out, tick, 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 so on and so forth, and just run it over and over again to find out if you could find maybe a rule that involves more features that has an even higher lift than 2.5. So this is totally doable in Excel. But what would be really nice is if you could do this in a lot quicker way, where you could have your entire table of data like we just saw, and we could just ask the market basket analysis to be like, look, circle through 2-way, 3-way, 4-way, 5-way rules with these particular constraints and just find me the best and just list them all off. And there is actually a very easy way to do this. And let me flip over to PowerPoint and I'll show you what I mean. All right, this is an example of what I mean. This output right here comes from the R programming language. And let me show you how awesome it is. You can see here I've pegged survived on the right-hand side. And then I've asked R to do a market basket analysis, mine me all of these association rules, and then list them in descending order by lift. And what you can see here is I've got combinations of 3 features, 2 features, a single feature, all that just done very quickly, very easily. In Excel, I could do this too, but it would take quite a bit of work. It'd be a lot of manual effort. And what I can't see, for example, very easily in Excel is, hey, what is the second best association rule with 3 features or the second best association rule with 2 features? I can't do that very easily in Excel because the solver only finds the single best thing. This is way easier, so much easier. And here's the cool thing. Learning R programming, if you already know Excel, is extremely easy. And I wouldn't expect you to believe me, so you can check up here and I'll have a video on my channel that you can take a look at. I'll also put it in the description as well. And you can see how easy it is for an Excel user to learn R programming and then do market basket analyses like these. And it is so much easier than doing it in Excel. You can totally do it in Excel, don't get me wrong, it's a fine tool, but if you're interested in having more power, there's nothing like R programming. If you're liking this video so far, would you mind helping me out and just giving me a like? That will tell the YouTube algorithm this is good content, and then more folks that might be interested in doing market basket analysis with Excel can see the video. Also, I'll put up some more videos on my channel here, just in case you're interested in learning more about R programming or some other things that you can do with data analysis. Okay, market basket analysis with Excel. Mining association rules is a wildly, wildly useful skill for any professional. Until next time, please stay healthy, and I wish you very happy data sleuthing.